Hello guys, this is Code and Code, and this is video editorial for the problem creating a schedule taken from Codeforces Educational Round 179, and this was D problem. The problem we'll solve using greedy and constructive algorithm. All right, let's have a look at the problem statement. So you are given n groups and m classrooms, right? Where each group has to attend 6 classes, right? So each group can have each class can have one group at a time, right? In a class at a time, you can only have one group, and we have n groups. So classroom names are assigned integers, and there will be at least 3 digits. And after removing the last 2 digits, you get the floor number. For example, 31215. This is the classroom number. Remove the last 2 digits, 15312 is the floor number, right? So, and what we have to do, we have to assign 6 classes for each group. We have n group. For each group, we have to assign 6 classes, and we have to assign a room number to them, right? In such a way that first, each classroom has only one group at a time. Second thing, the total movement of the group is maximized, right? We have stairs. So if I am on the 10th floor, if group 1 is on the 10th floor and they have to go for the next class on the 12th floor, the number of movement is 2, 10 to 11, 11 to 12, because we only have stairs, we don't have accelerators or lift, right? So now this is the problem statement. You are given n group, m classrooms. We have to assign each group 6 classes, and we have to assign them classrooms for 6 classes, right? And we have to do in such a way the total number of movements is maximized among all the groups, right? So if I explain the same with an example, it would be something like this. So I have one group and 3 classrooms, 512, 111, 1011. So if you see, this is on the 5th floor, this is on the first floor, this is on the 10th floor, right? I only have one group to assign 6 classes. So what I'll do, I'll assign it something like this: 111 1011 111 1011 111 1011. So the first class is on 11, that means on the first floor. Second class is on the 10th floor, so they have to move from first to the 10th floor, right? So the total number of movements will be 9. Same goes from here to here, again 9, 9, 9, and 9. 9 times 5, since there are 6 classes, there will be 5 movements, right? So 9 times 5, 45. This is the max you can achieve. 45 is the max you can achieve. Other configuration can be just opposite of this, like 1011 then 111, 1011 then 111, thing like that, right? So basically, if you take a look at this, we are assigning the classroom in zigzag manner, right? So this is the problem statement. So one of the constraint is that a number of classrooms are always greater than equals to number of groups, and m is less than equals to 10 power 6. I think it was 5, but you can confirm with the problem statement. I think it was 10 power 5, I'm not sure. Maybe it's 10 power 6, but we can still solve it using the algorithm that we have, right? So yeah, this is the problem statement. So let's look at the observation and how we are going to solve this problem. So observation number 1, to maximize the total numbers, each class has to make as much movement as possible between the classes, right? Each group, my bad, each group has to make uh, as much movement as possible between the classes, right? This is group, not class. I made a mistake. Now, what does that mean? That means that for each group, sorry, for each group, the first class should be on the lowest available floor, and the second one should be on the highest available floor, to maximize the movement between the classes, right? So and you can replicate this, basically zigzag this, right? So what do we and that's exactly what we did here. I assigned the first class of group 1 to 111, basically on the first floor, and the second one on 1011 on the 10th floor, right? So these were the lowest and the highest available rooms, and then I replicated it, right? So what we are basically doing, we are sorting the classroom by the floor number, so that we know which classroom is on the lowest level and which classroom is on the highest floor, right? So basically what we are doing, we are sorting and we are going greedy, right? That is observation number 1. Now observation number 2, what if we have more than one groups? For example, we have 2 groups and 3 classrooms. Again, classrooms are same, and this is the same example I have taken from the last example, right? This is the same. But what if I have another group? How do I assign room to it? As it might seem like 111 and 1011 are being used by group 1, and that is true. So it might seem that these two are already occupied, so group 2 can't use it. But that is not the case. As you might have seen here, at a time only one of these is being used by group 1. That means sorry, that means you can actually assign the other one to group 2. For example, for the first class, group 1 is using 111. At the same time, I can assign 1011 to group 2, right? It won't cause any issue. Now group 1 needs access to 1011. Same time, for the next class, group 2 don't need it. They can go to 111. So group 1 is on 1011 and group 2 is 1111, right? And similarly, you can replicate the same. So as you can see, two floors can be utilized, basically two classrooms can be utilized by two different groups to maximize the sum. So what we are doing, we are using the lowest and the highest, and using these two classrooms, I can assign actually the whole six classes to two groups using these two classrooms only, right? So you might have guessed how we are going to build the solution. The solution will be simple. Let's say we have five group and seven classrooms. I've only written the floor number, right? But in the input, you'll be given the whole classroom number, and from there you have to remove the last two digits. Now, what I'm doing here is that I've only provided the floor number so that we can discuss the solution easily. So we have five groups to assign, six classes each for each group, and we only have seven classrooms. So we are going to do it? First of all, let's create a 2D grid of n times 6, because each n group will have six classes, right? So n times 6 group n times 6 grid you will create. And then how we'll build the solution is this: we'll use two pointers, left and right, right? And using this, we are going to build the solution of each group, right? Now, how you can build the solution? You can build the solution in pairs. Using the LNR, I can actually assign classrooms to two groups, right? So LNR you can use to build two groups. Then again, L plus plus, R minus minus. Again, LNR you can use to assign the next two groups, right? So that's exactly what we are going to do. We will be processing groups in pairs, right? So I is equals to 1, right? And I'll increment by 2, right? So I is equals to 1 means I'm not starting from 0, I'm starting from 1. You can start from 0, so I'm starting from 1. When I is equals to 1, I'm processing I and I minus 1. So when I is equals to 1, I'm processing 0 and 1. I is equals to 3 because I'm incrementing I by 2. So I is equals to 3, I'll process index 3 and index 2, which is these two groups, so on and so forth, right? So when I is equals to 1, I'm processing these two, and for these two I have LNR like this. So I'll just keep on filling these two alternatively. So 111, 111, 111, 11, 1, 11, 1, 11, 1. So I plus equals to, now I is equals to 3. That means I'm processing index 3 and 2. But before that, once I have processed a certain group, I'll do L plus plus and R minus minus. Right? Now I'll use 1 and 9 to fill the next two groups. So 191919 and 919191. Done. Now again, L plus plus, R minus minus. So L and R are pointing to 3 and 5. And I'll increment I by 2. So I was 3. 3 plus 2 is 5, which is not less than n. 5 is not less than 5. So my for loop will exit. Basically, I want to process pair by pair. And for the last element, if n is odd, I won't have any pair, right? So if n is odd, what you can do after coming out of the for loop, you can simply alternate L and R here. So 3 5 3 5 3 5 for the last one, right? And you get your solution. As simple as that, right? So my bad. If you take a look at the solution, let me just increase the font size. My bad. Yeah. Can I? Yeah. Yeah. So if you look at the solution, it's something like this. I'll have t test cases. For each test case, I'm reading n and m, the number of groups and number of classrooms. Then I'm creating a vector for m classrooms, and I'm reading the classroom number, right? Once I have that, I'm sorting the classroom using the comparator that I have defined, right? And comparator I've defined like this, that I'm sorting based on the floor number. Right? Based on the floor number, not by the classroom number itself. And for to get the floor number, I've defined the function get floor. It will simply return classroom divide by 100, which basically means removing last two digits, right? So basically, I'm sorting based on the floor number. Once I have sorted it, I'm defining n times 6 2D array, right? Basically, vector of vector of n rows and 6 columns, n times 6. My LNR are 0 and m minus 1, right? And once I have this, the way I solved during the contest is this. So what I did for each index, uh, as you can see, I'm running for loop from 1 and incrementing it by 2. Basically, I'm processing it by pair, right? So what I'm doing here is that for each index, what I'm doing here, I'm only initializing the first element, right? For each pair. So what I'm doing is this. For group 1 and 2, only the first elements only, 1 and 11. I'll increment I, then I'll process 1 and 9. That's it. So I'm only assigning the first element. even though these two loops you can combine together, but during the contest I just write messy code. So I'm initializing the first element only using lnr pointers. Once I have done that, I'm filling up the next slots. Since k is equals to 0, I've already processed here, right? Starting from 1 to 5, I'm processing here, and for each index, right? For each group, for each group, starting from uh, again the same for loop, I'm going through all of the groups again, right, pair by pair. And for each group one, what I'm doing, I'm assigning their kth class using k minus 1th class. So kth class of ith index will be fetched from I minus 1th index, right? And kth class for I minus 1th index will be fetched from uh, k minus 1th class of ith index. So basically what I'm doing, since I have filled the first index of each group, so 111, 19 I've already done. Now I'm filling up the next indices, right? So this comes from k minus 1 I minus 1, right? Sorry, this comes from k minus 1 I, and this comes from k minus 1 I minus 1, right? Basically just take the previous element, right, for each group, right? For this it would be this element, for this it would be this element. Now you are filling this again from the group 2. This will be fetched from group 2, and this will be fetched from group 1. Basically I have assigned the 0th class, and then I'm filling up the next classes using the previous classes. As simple as that. You can that's what I'm saying, that these two for loops you can actually combine together, but during the contest I just write messy codes. So once I have everything, since I was processing the groups in pairs, it is possible that n was odd. If n was odd, for the last group I have to fill it manually using lnr, right, left and right. So that's exactly what I'm doing for each class. Basically for the last group, for each class, if it is odd, I'm using the left uh, pointer, otherwise I'm using the right pointer, and this will take care of the odd classroom, sorry, odd group. Once you have filled, you can print the solution. All right, yeah. So this is how you solve this problem. And one more thing, uh, you can check out uh, this repository that I have created. There are so many solutions from CSES, Codeforces, thing like and Spoj and many other places, right? So you can find many solutions here. So yeah, this is how you solve the problem. Uh, schedule. What was it? Schedule classroom problem, right? So yeah, this is for this problem. Thank you guys for watching. And till the next video drop, keep coding. Thank you.